Hi everyone and welcome to our channel. I'm Julia from Somatosoft. Today, I'll try to explain the security of the Internet of Things in just over 6 minutes. Imagine your office splurges on a new coffee machine. It ships with default credentials. You connect it to your office Wi-Fi to receive timely software updates. That one weak device can become an entry point into your operational network. But first, let's define Internet of Things security. IoT security is a set of cybersecurity measures that protect the entire life cycle of network of connected devices. This includes manufacturing, onboarding, operation, and updates. Think in 5 layers: device hardware and firmware, the local network, gateways, cloud services and APIs, and companion apps. Good security coordinates controls across all 5. The common paths for attacks are cloned or anonymous devices that join your network, unsigned firmware, updates without rollback protection, exposed tokens. These are just a few paths for threats to your IoT network. Kenneth Ginsberg once defined the 7 C's of resilience: competence, confidence, connection, character, contribution, coping, and control. In IoT security, we also follow 7 controls that mitigate risks and enhance resilience. 1. Strong device identity. Each device should have its own security certificate or a cryptographic key that is generated, stored, and managed within a trusted platform module chip from a public key infrastructure. 2. Secure boot and trusted firmware. Make sure to verify signatures at boot and block on-site images. 3. Signed over-the-air firmware update with rollback protection. 4. Least privilege and segmentation, no flat networks. This approach prevents attacks from spreading across the entire network, containing them within a segment, and reduces the overall attack surface by minimizing the points of entry and movement for potential threats. 5. Data protection. Ensure transport layer security in transit, encrypt secrets and logs. 6. Observability. Protect the integrity of system logs by making unauthorized changes or deletions detectable. Monitor fleet health by implementing anomaly alerts that establish a baseline of normal operations and flag deviations using machine learning and historical data. Actively track software bills of material to identify components and their versions. You can use this data together with your anomaly detection system to trigger alerts for unusual or outdated components within your fleet software. 7. Manage the lifecycle of keys and certificates. Reduce the impact of compromised credentials through key rotation and certificate expiration. Proper procedures for retiring a device include revoking the associated certificate and securely wiping its keys to prevent data breaches and unauthorized access. So, how do these controls come together in real life? Here is the minimum architecture we recommend. Keep devices on a segmented network with egress only to a gateway. The gateway verifies each device's identity, terminates TLS, and brokers traffic to your APIs. Updates and configuration flow from a signed release pipeline to devices. Operators use audited workflows through the gateway. If your devices are tiny or your fleet is older, start with isolation. Use lightweight crypto and a bootstrap key that immediately rotates to your certificate. For legacy gear, add a gateway proxy and phase inside updates as your next step. Track 5 numbers: % of devices with unique identity, signed update coverage, mean time to patch, number of exposed services per subnet, and mean time to detect incidents. These are the indicators that show real progress in IoT security. In short, protect the whole lifecycle: threat identity, updates, network rules, and monitoring as one system. Start small, measure progress, and improve steadily. Thanks for watching.